Hello learners, welcome back. In this video, we are going to solve a question from the properties of fluid which has been previously asked in the ESE examination worth 10 marks. So without any further ado, let's start with the question. The question states that a plate with a surface area of 0.4 meter square and weight of 500 Newton slides down an inclined plane at 30 degree to the horizontal at a constant speed of 4 meter per second. If the inclined plane is lubricated with an oil of dynamic viscosity of 2 poises, find the thickness of the lubricating film. So this was the question. All the data are given to you. Let's start solving this question. Before that, let me draw the diagram for you. So here goes the diagram. The diagram says that there is a plate of surface area 0.4 meter square. So here I have drawn the plate of, this is the plate of area 0.4 meter square. And please remember that this is the cross sectional area of the plate. We are viewing the plate from the side and we are not talking about this area. No, we are not talking about this area. Then what area are we talking about? We are talking about the top area of the plate, which is inside the plane of this paper, okay, which is inside the plane of this screen. The plate is something like this. So what we are seeing here is the thickness of the plate or the cross section of the plate. And what data is given to you? The data given to you is the area of the plate. That means the plate is rectangular or of any shape, but the area of this plate is 0.4 meter square. And what is given to you is that the weight of the plate is 500 Newton. So weight of the plate which is acting like this is given to you as 500 Newton. And it slides down an inclined plane at 30 degree to the horizontal. So this plate is sliding here to the inclined plane which is inclined at a 30 degree angle to the horizontal. Okay, now what is given is that the speed of the plate is constant and it is 4 meter per second, 4 meter per second in this direction. If the inclined plane is lubricated with an oil, so this here you can see the dashed lines, these are the oil film. And what is the dynamic viscosity of this film? The dynamic viscosity of this film is given as 2 poise. Okay, and what we have to find out? We have to find what is the thickness of this film. We have to find the thickness of this film. Let it be T. So I have just explained you about the question. Now let's start solving this one. So what are the given parameters? The area of the plate is given to you, the velocity of the plate is given to you, the angle is given to you, viscosity of the fluid is given to you, and the weight of the plate is given to you, and you have to find the thickness of the film. So let's assume that the thickness of the oil is T. Okay, let's assume the thickness of the oil is T. Let me write it down. Now you see one thing, the plate is moving at a constant velocity. It is not accelerating. Okay, the plate is moving with a constant velocity of 4 meter per second. It is not accelerating. That means whatever force is acting in the downward direction is getting neutralized by the force in the upward direction, right? Now what sort of force is acting in the upward direction? Definitely this viscous force is acting in the upward direction, and this viscous force or the force of friction is acting on the surface of the plate, right? It is acting along the surface of the plate in the upward direction. So that means this force must be equals to the force acting in the downward direction, and these two forces are equal and opposite in direction. That is why the plate is moving at the constant speed. So here is the crux. Using this hint, you are going to find the thickness of the plate. So once you know the downward force, what is this downward force? It is the force due to gravity, right? And what is this force? This force is the force of viscosity or the force of friction. So how are we going to find out the force? This force, I mean to say. How are we going to find out the force? We know that from Newton's law of viscosity, shear stress is equals to mu du by dy, right? So Newton's law of viscosity states that shear stress is directly proportional to rate of shear strain of a Newtonian fluid, and this mu is the dynamic viscosity of the fluid. It is the proportionality constant. We all know this. Now, so here, if you see carefully using Newton's law, what is the velocity here? The velocity of the fluid in the upper layer, which is touching the plate, is u. That is, it is 4 meter per second. But the velocity of the fluid which is touching the inclined is 0 over here, right? And this thickness is t. So this is what we are going to apply here. We know that stress is equals to force per unit area, right? And what is force? This force is exactly same as this force, right? The force acting in the downward direction due to acceleration due to gravity. So let me write it down as force by area is equals to mu du by dy. Now what is that force? The force of friction or the force due to viscosity is same as the force due to gravity, right? Now this force due to, what is the force due to gravity? It is 500 Newton given to you. So 500, but it is acting in the downward direction, right? This 500 is acting in the vertically downward direction. So its component in this direction will be how much? It will be 500 into sine of theta, right? 500 into sine 30 degree by area. What is the area? Area is given to you as 0.4 meter per second, sorry, 4 meter square, 0.4 meter square. Now what is this dynamic viscosity over here? It is given as 2 poises, and let me tell you, this poise is not a standard unit. It is a CGS system. CGS, in CGS system it is poise, but the standard unit of poise is Newton second per meter square, and you should know that 1 Newton second per meter square is equals to 10 poise. This relation is very important. 1 Newton second per meter square is equals to 10 poise. So it is given as 2 poise. So 2 poise means 0.2 Newton second per meter square. So we will put the standard units only. We are not going to put 2. Instead we are going to put 0.2. Right? Now what is du by dy? Du is change in the velocity with respect to distance. So what was the velocity over here? The velocity over here was 4 meter per second. And what is the velocity over here is at this point was 0. So total velocity difference was 4 minus 0. And what is dy? Thickness, which we don't know, and we have taken it as t. Now using this equation we have to solve for t. Let's do that. So now 500 sine 30 is how much? It's 0.5 by 0.4. This 0.2 I am bringing here, 4 by t, or actually you can write t as t is equals to 4 into 0.4 into 0.2 by 500 into 0.5. If you solve this, you will get the thickness of the oil, which is the required quantity. So let me solve this and directly write the answer for you. So it is coming out to be 1.28 into 10 to the power minus 3, and it is in meters, okay? Because we have taken everything in the standard quantity, and this will come out to be, if you write it in millimeters, you will get the answer as 1.28 millimeter. As simple as that. So hope you understood the question and how to do this. It was a very simple one. Thanks for watching. Do like and follow me for more.